Hi everybody. Today we're gonna make some basic structural analysis with using Revit, Rhino Insight, and Grasshopper. Let's get started. First of all, to make this analysis, we need a model in Revit. So I I prepared a model. Actually, I had a model as a midterm assignment, so I use it as the base and I add some elements on it. I'll explain later. First of all, let's open the Rhino here and also Grasshopper. I don't have much time, so I'll explain quickly. First of all, to do this analysis, we need to import some elements on Revit to Grasshopper. How to do that? Actually, we need to know that Grasshopper defines elements as simple curves or surfaces. First of all, for example, our columns and beams uh, defining Grasshopper as simple curves, and our floors, generally roofs, defining as simple surfaces. We need to make that. To do that, also in Revit, we need to add some structural columns and structural beams on our model. If we add architectural columns from here, for example, it will be a problem because we need some information about the material actually. It can be material, it can be dimensions. To calculating the structural analysis, we need this specific information. Because of that, we need to add structural elements, columns, beams, and floors, etc. Then, after we prepare our model, we need to open the Grasshopper. First of all, this area getting information from Revit to Grasshopper. For example, this is for our structural columns. This definition for the columns. And then we need to define this column as line here. Then also we need to define our beams as curves like that here. And then finally we have a floor. We need to define this floor as a simple surface in Grasshopper, and this definition also for that. Then, after we define these simple curves and surfaces, we need to use some components of Karamba 3D and connect these units as the structural model. And this component helps us in this situation. These simple curves as columns, simple curves as beams, and simple surface as floor are elements. To do these calculations, we need also, of course, supports and a load. For this example, we will use just gravity force as a load. And also for the supports, we will use our foundation points actually. And to find this foundation points, we can do this. We need to find the bottom part of our columns, and we need to convert this bottom part into points. I'll show you. This is the bottom part. You can see the green cross. These are working as our foundation, actually. Then we can define our support. And finally, we need to analyze this model. For this operation, we have analyzed component in Karamba, and this component calculates the force, displacement, gravity, etc. The result is here, actually. This means this 38.5 means it's impossible to construct this model in real life because the 35 centimeters displacement is very dangerous. But this whole definition as an example, so it's not a problem. It works actually. And lastly, we have Galapagos example here. This Galapagos makes the calculations for us and giving us the best result for the thickness of the beam or height of the beam or height of the floors. When you double click on it from solvers, let's say start solver. When Galapagos starts to solve our system, it shows us the actually best option for our structural system. It takes a bit time, but I will show you a result. I need to show you. Yes, this blue area, for now, it means nothing, but this blue area is decreasing, the time goes, and we have one black bold line on the middle of this blue area. This black line means the optimum height and width and etc. The blue area is our current structure. So this blue area always goes to black bold line to find the best option. And stop solver, these are the options. We can choose one of that and reinstate. When we click reinstate, it sets our definition as the best option here. For example, the height and width of the beams. I know these are impossible examples, but the main thing is this definition works or not, and it works actually. And lastly, we have one more section here. These are for the visualization, for the displacement. But in my computer, I guess I have a problem with this. It looks fine, it looks work, but it's not actually. When we open the preview of it, there is no displacement here, but actually there. We can see here we have 38.5 centimeters displacement, but we cannot see this here. I think this is not a problem because Karamba is not a visual cool thing. It's about the analysis, and our analyze definition works well. And that's all. Thank you for coming.